So I think we've all felt this at some point. You're using some project scheduling software, you input all the facts, you hit calculate.
And suddenly the project is 3 weeks late.
Exactly. And it gives you absolutely zero explanation as to why. That's the pain point we're talking about today, is that frustrating black box of project management.
And that black box, it just completely corrodes any sense of trust. The output looks wrong, so you start tweaking the inputs to try and make it look right.
Right.
But you have no audit trail. You don't understand the engine's logic. So project managers end up chasing the tool, basically trying to trick the algorithm instead of actually managing the project.
I completely agree with that premise. And that lack of trust is what we are deep diving into today. Our source material isn't just a white paper, it's a whole stack of internal design documents.
Yeah, we're talking RFCs, READMEs, the core architectural plans for a brand new scheduling engine called utf8proj.
And our mission here is to explore what its designers are calling explainable project scheduling.
They're promising, radical transparency, deterministic calculations, and schedules you can actually version control with Git, and maybe most important of all,
A traceable reason?
a completely traceable reason for every single change to every single date.
And the sources frame this right away by contrasting it with the old way of doing things. Traditional tools with their hidden proprietary binary formats and these silent autocorrections.
Whereas utf8proj demands plain text files. This .prod format, which is obviously Git-friendly, you can diff it. And it uses diagnostics to explain the constraints instead of just quietly fixing your broken model.
It's like they're taking the rigor of software development and applying it directly to planning.
And that whole commitment starts with their core philosophy, which is summed up in this one phrase: describe, don't prescribe.
Okay, what does that mean in practice?
It means the engine isn't there to force you into a certain methodology or tell you how to run your project. It's just there to take your description of reality, your tasks, your resources, your dependencies, and then explain why the schedule is mathematically forced to be what it is.
And the main way it does that explaining is through a very deliberate engineering choice. This massive, very specific diagnostic catalog. This isn't just a generic error, is it?
Oh, far from it. We're looking at over 40 specific codes, and they all link directly back to the task or constraint that's affected.
And they're categorized.
They are. You have the E codes for hard errors, things like a circular dependency that make the schedule flat out impossible. Then you have W for warnings, resource over allocation, maybe a cost range that's just way too broad.
And then it gets even more granular. I saw there are 23 specific C codes just for calendar issues.
Right, so it doesn't just say calendar problem.
Yeah.
It tells you precisely which calendar rule was broken and which task got moved because of it.
And then the L codes for leveling.
Correct. L001 through L004. They specifically detail resource leveling decisions. The whole point is that transparency is engineered right into the failure state. If a date shifts, you can check the output, see L003 on a task, and the docs will tell you that means task shifted due to contention with a higher priority task for resource blob.
The black box is gone.
The black box is gone.
But, that level of detail only really matters if the engine itself is trustworthy. Which brings us to the tech. They position this as a modern CPM ear engine for developers and automation pipelines.
Right.
So what were the big engineering choices they made for that audience?
Well, the first and probably biggest choice was building it in Rust. This solves a huge deployment problem. If you look at older, powerful engines like Task Juggler, they often need a whole ecosystem, like a Ruby runtime.
Right, dependency hell.
Exactly. In an enterprise environment or a CI/CD pipeline, that's a nightmare.
So why Rust?
It gives you a modern single binary with zero runtime dependencies. You drop the executable on a server or in a pipeline, and it just works. Plus, you get memory safety and incredible speed, which is obviously crucial for complex critical path method or CPM calculations.
So they're not trying to be the next big GUI application. They want to be the most trustworthy scheduling utility.
That's it, precisely. And to get that trust, you need absolute mathematical rigor. And this led to a really critical architectural pivot that's detailed in RFC 0002.
Okay.
They realized early on that a lot of existing tools blur two very distinct concepts, which can lead to mathematically impossible results.
And that's the difference between the organizational structure and the logic structure.
That is it. They force a strict separation. The WBS, the work breakdown structure, is purely for presentation. That's how you see the tasks organized. But the DG, the directed acyclic graph, is for scheduling only. That's the raw dependency logic.
Why is that separation so critical? What breaks if you mix them?
You start violating core CPM invariance. The worst result, and it's a common one, is the calculation of negative slack.
Which is impossible in reality.
It's scientifically impossible. It means your math is broken, not just your plan. So by forcing this WBS-DAG separation, they can test the solver against 8 specific CPM invariants. It guarantees predictable, correct results. That's the foundation of their promise of trust.
So if they're that meticulous about the math, how do they handle the messy human side of defining constraints? I saw this rigor also dictates their rules on container dependencies, which is a huge shift from other tools.
Yeah, this is maybe the most opinionated part of their design. It's in RFC 0003. They are deliberately moving away from tools like Microsoft Project.
Where you can put a dependency on a summary task and it just flows down.
It flows down silently. And the utf8proj says a very firm no to that. The core rule is container dependencies do not flow down. You must explicitly declare constraints on the leaf tasks themselves.
Okay, but doesn't that create a ton of friction for project managers who are used to that convenience, the whole set it and forget it thing?
It absolutely creates friction, but it's what they call necessary friction. It's critical for auditability.
How so?
Well, imagine you have a really nested WBS. If you reorganize it, you might move a summary task and accidentally break 100 hidden dependencies on its children without even knowing.
But in a text-based, Git-friendly world, that's a disaster.
Exactly. Explicitness is king. Every constraint has to be visible right there in the task definition.
So how do they handle migrating users who are used to the old way?
They don't just break the import. When you bring in an MS project file, utf8proj will emit a specific warning, W010.
The MS project compatibility warning.
Right. It flags those implicit dependencies, gives you the warning, and then offers an autofix to make them all explicit on the child tasks. It basically forces you to adopt the auditable model.
It's a teaching moment.
It's a genuine teaching moment about better scheduling hygiene.
And that transparency carries over into progress tracking too, right? That's another place where things can get messy in legacy tools.
Yes, RFC 0008 covers this with what they call progress-aware CPM. The solver respects a specific status date. You can set it from the command line, in the file, or it just defaults to today. And that date locks everything down.
So completed tasks can't be moved by the algorithm.
Exactly. A task that's 100% complete is locked to its actual finish date. History is history.
And for tasks that are only partially done?
The solver just schedules the remaining work starting from that status date. But here's where it gets really clever in modeling real-world chaos. Inconsistent status reports.
Give me a scenario.
Okay, so a task was originally 100 hours. The team says it's 50% done, so 50 hours are used up. But then they also say their current estimate is that it still needs 80 more hours to finish.
So the numbers don't add up. 50 plus 80 is 130, not 100.
Right. The inputs conflict. A normal tool might just silently pick one number and ignore the other.
But utf8proj forces you to confront it.
It does. It lets you set an explicit remaining duration. That's the 80 hours. And that takes precedence because that's the team's current reality.
But it flags the inconsistency.
It flags it with a P005 diagnostic.
Yeah.
So it prompts the user to go back to the source file and clarify the discrepancy. It refuses to silently blend conflicting information.
That feels like it maintains that strict control while still respecting that execution is messy. Let's shift gears a bit to the very beginning of a project where there's a ton of uncertainty.
Right.
How does utf8proj model planning when you don't even know who is going to do the work yet?
This is RFC 0004, which introduces a concept they call progressive elaboration. They get that planning moves from these early, range of magnitude estimates to detailed execution.
Okay.
So to model that, honestly, they make a distinction between resource profiles and concrete resources.
So a resource profile is an abstract role, like back-end dev or senior architect?
Exactly. And a resource is a specific person, Alice or Bob. And early on, you can assign tasks to a profile. And that profile can carry an explicit cost range, a min and max. This lets you honestly model your uncertainty. As you refine the plan and assign actual people, that cost range should get narrower and narrower.
And this whole refinement process is governed by something called the refinement lattice.
Yeah, and they're very specific about this. They say this is not object-oriented inheritance. It's about set narrowing.
What does that mean?
It means when you specialize a profile, say you define a senior backend dev that specializes the general backend dev profile, that new profile must narrow the constraints. You can't widen the cost range or remove rules from the parent.
And of course, they use diagnostics to enforce this. What's the R100 error, the one about specialization ambiguity?
Okay, so let's say you have Alice.
Yeah.
And she's very skilled. She could be a back-end dev or she could be a security architect.
Right.
If you try to say that Alice, the concrete resource, specializes both of those abstract profiles at the same time, utf8proj throws error R100.
It forces you to be clearer.
It forces you to clarify the project structure. You have to create a single new composite profile, maybe security backend lid, that Alice specializes. It prevents any ambiguity in where costs are coming from.
And the tool actually nudges you towards this refinement, even if the schedule's technically okay.
Oh yeah, you'll get hints like R001 if a major task is still assigned to an abstract profile as you get closer to execution.
Yeah.
And there's a much sharper warning, R001, if a scope's cost range is just too wide, like plus or minus 25%.
Which suggests your uncertainty isn't being managed properly.
Exactly.
That brings us to what is probably the ultimate black box: resource leveling. This is usually where a tool just takes your inputs, runs some magic algorithm, and spits out a new timeline with zero explanation.
And this is where they are defiantly different. It's in RFC 0005. They basically stop halfway.
Halfway.
Phase 1 of resource leveling is fully implemented, and it is completely deterministic. It finds the overallocation, and it explicitly explains why a shift is needed using those L codes we mentioned before. It'll tell you tasks X, Y, and Z are all competing for Bob on Tuesday.
But they deliberately deferred phase 2, the actual optimization part, the task splitting, the shifting to find the best outcome. Why would they leave that on the table?
The trade-off is integrity over convenience. Their whole philosophy is that utf8proj doesn't optimize your project for you. It tells you exactly why it cannot be done as written.
So optimization is seen as a way of hiding problems.
They call it optimization creep. The solver silently hides the fact that the underlying plan is just not feasible, which gives you a false sense of security. By deferring phase 2, the tool forces the human to actually confront the resource constraints and make the trade-off decisions themselves.
And that preserves the audit trail.
It preserves the full audit trail.
It really feels like the entire architecture is designed to empower the human, not replace them.
Shifting to outputs. Given this focus on developers and automation, what makes their output formats different?
They're all about structured data. So you have JSON, SVG, and key formats for documentation, like Mermaid and Plant UML. But there's one huge differentiator for the traditional PMs.
The Excel export.
The Excel export. And it's not just a static beta dump. It's a multi-sheet workbook with formulas intact. That means the output is still dynamic. You can keep working with it outside the core engine.
That's a great feature. But what about usability for huge projects? It can be overwhelming.
They address that with the focus view, which is in RFC 0006. If you have 1,000 tasks, you don't want a Gantt chart with 1,000 lines.
No.
So you can use the focus and context depth flags to generate a chart that only expands the specific part you're working on, say task 6.3.2, while collapsing everything else into summary bars.
So you get the deep detail where you need it, but you don't lose the context of the overall project. Exactly. It's usability engineered for complexity. And all of this, the focus on structured outputs, it leads directly to their most forward-looking design, the AI assistant integration in RFC 0007.
This is where it becomes AI native. What does that really mean technically?
It means they're exposing the entire CPM solver logic to outside tools in a structured way. The whole engine is compiled to WebAssembly or WASM, so it can run right in your browser. And this WASM playground exposes a JavaScript API called window.udf8proj.
And why is that better than just letting an AI plugin read the raw text file?
Because the AI can perform structured queries. It can ask the scheduler, give me the total slack for this subgroup, or list all tasks that become critical if resource X is delayed by a week.
So it's querying the mathematical model directly. It's not trying to guess based on the text.
Exactly. It's far more powerful and reliable for doing critical path analysis or getting resource leveling advice.
That's a key distinction. The AI is leveraging the deterministic engine, not trying to replicate it.
And that reinforces their main design principle here. AI is the translator, not the controller.
Okay.
So the AI can suggest and explain things. It might say, hey, if you move task 4.1 to Bob, the critical path shortens by 4 days. But the human has to be the one to actually make that change in the text file.
Keeping that audit trail completely intact.
Exactly. It preserves the trust they've built into the entire system.
What stands out to me across all these design documents is that consistent commitment to trust. From the very first decision to use Rust, all the way to this final AI API structure, they've defined one problem, the opaque scheduling black box, and they've just relentlessly solved it with transparency.
That's the whole value proposition.
Yeah.
utf8proj makes a very deliberate, almost philosophical choice to trade solver magic and convenience for something that is auditable, deterministic, and explainable.
Right.
By using Git, plaintext, and all those specific diagnostics, they are putting the control and the responsibility right back into the hands of the human planner.
Which, as we wrap up this deep dive, raises a really important question. The sources are very clear on the rule. The human decides, the AI translates. But as AI gets more and more integrated into these critical tools and its suggestions get more persuasive, how do we make sure that this explainability manifesto stays the standard? If we start relying on an AI to just quickly resolve all our resource conflicts, what are the ethical and technical guardrails we need to guarantee that we never, ever sacrifice that auditability for sheer convenience?
That's the tension, isn't it? If the system is designed to explain its failures, the future challenge is making sure the AI isn't designed to obscure its advice.
Yeah.
It's a conflict between speed and integrity that I think every project manager is going to be facing very soon.
We'll leave that with you to mull over.